So hello and welcome to my channel. Today our topic of discussion is Coulombs Law, and we will be starting with the Coulombs Law. And before starting with Coulombs Law, we would learn some of the basic parts in it, that is some of the basic concepts, that is charge. What is charge? Charge, it can be positive or it can be negative, and if there are two charges present, one is positive and another is negative, they attract each other, and if two positive charges are there, they repel each other, and its unit, SI unit of charge is Coulomb, SI unit. And also, that is, the charge E, its value is 1.6 into 10 to the power minus 19 Coulomb, and that is charge of an electron. It is generally taken as negative, and charge of a proton, that is taken as positive, plus E, that is 1.6 into same 10 to the power minus 19 Coulomb. Then next comes our topic, that is quantization of charge. The quantization of charge, it states that the charge that can be given to a body, that only it can be integral multiple of the charge of an electron, that is 1, 2, 3, and it is always an integer. It can be only integer value, and when it occurs in that of the free state, but in combined state, in quarks or glucons, it it can occur in fraction, means it can remain in that of the fraction. Next our topic is that is conservation of charge. The conservation of charge, it states that the total charge of an isolated body is always conserved. The charge can neither be created nor be destroyed. The charge always of a body always remains constant, or any process there the charge always remains conserved. That is, for example, in radioactivity, we are taking one example, that is in beta minus decay, one neutron is there and it undergoes dissociation into proton and that of the electron, and it forms a neutrino. So before the reaction, it is found that the charge of a neutron has no charge, so it is 0. Proton, it has plus 1 charge, electron has minus 1 charge, and neutrino has no charge. So total charge on left hand side of the reaction and the right hand side of the reaction is totally the same. So we find that the total charge of any process is always conserved. Next our topic is Coulombs law. We come to the main topic of discussion, that is Coulombs law. That is, if there is any two charges, that is Q1 and Q2, either let be it positive, and if it is negative charges, and if they are placed at distance r, so force between them is given by F equal to K Q1 Q2 by r square, and the unit of force, that is unit is Newton, and here are some important value, that is we are writing as K equal to 1 by 4 pi epsilon naught, and its value is written as 9 into 10 to the power 9 Newton meter square Coulomb square per Coulomb square. And also epsilon naught, it is known as permittivity of the free space, and its value is 8.85 into 10 to the power minus 12, that is Coulomb square per Newton meter square. And also there is one concept, that is epsilon by epsilon naught is equal to epsilon r, where epsilon is the permittivity of any medium and epsilon naught is permittivity of the free space. So we can easily write epsilon equal to epsilon r into epsilon naught. That is one important formula, where epsilon r is relative permittivity and epsilon is the permittivity of the medium in which we are keeping it, and epsilon naught is the permittivity of free space. So we can write here value for air epsilon r is originally taken as 1, so we are writing it as 1 by 4 pi epsilon naught. Okay, and we will take one small question, that is one basic question, that is it written that the two charges, that is q1 and q2, it is equal to same and it is 1 coulomb, and they are placed at 1 meter apart. So force between them is equal to k q1 q2 by r square. So on putting the value, we will get that force equal to 9 into 10 to the power 9 into 1 into 1 by 1, and its unit is Newton, is equal to 9 into 10 to the power 9 Newton. So with this we come to the end of our today's lecture, and hope you have understood. So please to like, share and subscribe to my channel and share this video, and also stay tuned for more exciting updates and more video. Thank you.